Hey, this is chapter 3.5 to 3.8, and we're going to be covering matrices, specifically multiplying, Cramer's rule, and inverses. So 3.5 is titled Perform Basic Matrix Operations, and we're going to first define what a matrix is, and that is a rectangular arrangement of numbers in rows and columns. So the dimensions of a matrix could be 2 by 3, for example, so that means 2 rows and 3 columns. So we could have the numbers 4, -1, 5, 0, 6, and 3 as our elements or numbers in our matrix. Now, two matrices are equal if they share the same dimensions. So if we had another matrix that had the same 2 by 3 dimensions, then it would be equal to this one. So next we're going to be talking about adding and subtracting matrices. Now, let's talk about adding. We have two matrices here, A, B, C, D, and E, F, G, H. And we're going to add them by taking the corresponding element of each matrix and adding it. So we get A plus E, and then below we have C plus G. In the top right we have B plus F, and finally D plus H. Now you can see how these all correspond because we have, for example, C in the bottom left and G in the bottom left, so we add C and G. This is the same for subtracting. So now we're going to be using actual values as our elements. So perform the indicated operation. The first problem, A, is an addition of matrices. So we're going to follow the exact pattern that we just did. We have 3 plus -1, 0 plus 4, -5 plus 2, -1 plus 0, and then simplify. So we have 2, 4, 3, and -1. And this is our final answer. So for problem B, we're not only subtracting this time, but we have a different matrix. It has different dimensions. So we're still going to follow the same pattern, that is assigning, or not assigning, but solving each corresponding element that is in the same position. So we'll start with 7 minus -2, 0 minus 3, -1 minus 3, and then we have 4 minus 5, -2 minus -10. Be careful with when you're subtracting negatives, because you need to remember that we're just subtracting in general, but we also have a -10. And then finally we have 6 minus 1. And then we'll simplify this, and we get our final answer. Next we have scalar multiplication, and a scalar is another word for this number here, which we're going to multiply by each of the following elements. So it really isn't that difficult. It's kind of like distributing, but we're going to take -2, multiply it by 4, by 1, by 2, etc. We can simplify this. So we get -8, -2, -4, 2, 0, and 4. -14, excuse me. And this is our final answer. Next, we are going to do a scalar multiplication, but with addition. Now, our first step is always going to be the multiplication. So first, we're going to multiply this matrix by the scalar, and then we're going to add this matrix to this matrix. So this is what our first matrix looks like once it's been multiplied by the scalar, and now we're going to add it to our second. So plus -3, 6, 8, and -5, and then simplify. So this is our simplified scalar matrix, or scaled, I guess you could say. It's not the official term. And then we're going to add it, like I said. Our simplified answer is -11, 26, -24, and -5. So 3.6 is multiply matrices, and we have a requirement for multiplying, that is, the number of columns in the first matrix must equal the number of rows in the second. So we have two matrices here, 1, 2, and the first one has two columns, 1, 2. The second one has two rows, so therefore, yes, we can multiply them. Now, another point is that the product matrix's dimensions are the product of the rows of the first matrix multiplied by the columns of the second. So we have 4 rows, 1, 2, 3, 4 in the first, and 3 in the second. So therefore, our product matrix, the resulting matrix after we multiply these, will have dimensions of 4 by 3. So let's see what our matrices would look like multiplied if we just use variables a through h. So we have our two matrices here, a through d and e through h, and we see that we're going to first multiply this column by e. So this is aligning with this element, so both left corners, a times e, and then we're going to add that by the second one in the row by the second one in the column. So first, again, we have the first in the row multiplied by the first in the row. Then we have added to that the second in the row by the second in the column. So we're always moving in rows here and columns here. So a times e plus b times g. So the next one, we will have c by e plus d times g. So this time we're moving in columns still. We're moving in rows. So we have c and d, and then we're still moving in columns. We have d times g. So c, e, and d, g. So we have c and d and e and g. Next we have a and f and b and h. So again, we have rows and columns. A is with f, b is with h. Finally, we have c with f and d with h. So rows and columns, Always remember that rows are horizontal and columns vertical. So let's move to an example with actual numbers. And remember, we need to first ask ourselves if this can be multiplied in the first place. And that is the requirement that we have to have the same number of columns of the first as there are rows in the second. So yes, this works. We have 2 and 2. So let's multiply. We have our first column with 4 and 8. So we have 4, and we have our first column and our first row. 4 is by 5 and 8 by 9. So we have 4 times 5. And then we have 8 times 9. Next we have 0 times 5, and this is plus 2 times 9. And then we have 1 times 5 plus 6 times 9. Do you understand how we get this? We have 0 and 5, 2 and 9. 1 and 5, 6 and 9. We're always moving in rows here and columns here. So we've just dealt with the first column here, so now we're going to move on to 4 times 2 plus 8 times 2, or 8 times 4, 8 times 4, because remember we're moving in, that was my mistake, we're moving in columns. So next we have 0 times 2 plus 2 times 4, and then 1 times 2 plus 6 times 4. And then we simplify. We've simplified the multiplication, and now we just need to keep simplifying. So next we are going to add these, and then finally we'll have our answer. And this is our final answer. So chapter 3.7 is evaluate determinants and apply Cramer's rule. The determinant of a matrix A is denoted by DETA, or what looks like the absolute value of A. So the determinant of this matrix here would be, we can take this symbol, like as if it's the absolute value, again as I said, and we have A, B, C, D. So first we're going to repeat the first two columns. So we've done that. We've repeated the first two columns to the right of the determinant. We have first, second column. And then we're going to subtract the sum of the red products from the sum of the blue products. I'm reading this from the textbook. So our red products are, these are our red products. We're going to multiply B and C. So CB on this side. And our blue products, those are AD. So we're subtracting our red from our blue. So let's use some actual numbers. So we have, the instructions are to evaluate the determinant of this matrix here. 5, 4, 3, 1. So we're going to take the product of these two, which is 4 times 3. And we're going to subtract that from the product of these two, which is 5 times 1. So our answer is 5 minus 12, which is negative 7. So let's move on to a more complex example. Instead, this time we have a 3 by 3 matrix, but we're going to follow the same steps as before. So we can ignore this equal sign here, but we're going to repeat the first two columns of this matrix to the right. So we have 2, no, it's in red. That should be in white. 2, negative 1, 4, 1, 3, negative 4. And then we're going to follow the same pattern as we did before with using the diagonals. So we have our blue diagonals. So we have 3 of those. We have 1, 2, 3. And these will be the multiplication of these 3. So we have 2 times 1 times negative 2 plus, and this is just a bracket, it's not in a matrix, plus the next 3, which is 1 times 0 times 3, plus negative 3 times 4 times negative 4. This whole thing, and then we subtract the red diagonals. So the red diagonals, there's also 3, 1, 2, 3, and these are those 3. So we have 3 times 1 times negative 3 plus negative 4, 0, and 2 plus negative 2, 4, and negative 1. So this is just one big subtraction problem. And if you want to use these arrows from the original problem, we can say that this 2, oh, that should be in blue. We have this one coming here, this here, this here, and then our reds we have, oh, that's again not in the right color, sorry. We need to have the 313, 402, and finally our negative 2, 4, and negative 1. So that's where those all come from, and then we're just going to do our big subtraction problem. So we simplify that, and then we get our next step, which is more simplifying. So we have 44 minus negative 1, which is 45, and this is our answer. So the second part of this section deals with Cramer's rule, which is a way to solve a linear system by applying it to a matrix. So as you can see, we've taken the coefficients, the A, B, C, D, E, and F, and applied A, B, C, and D to the coefficient matrix. So we move from the linear system to the coefficient matrix. So for example, we will be told to evaluate this system for a solution. So the first step is to write this in a matrix. So we have 9, 4, 3, and negative 5. Now take this from the form here in which the A, B, C, and D are in this form. So if you just relate these in the same way, then we get 9, 4, 3, and negative 5 in this arrangement. Next, we move to solving the determinant to see if it is 0, because if it is not 0, then it cannot be solved. So this is just a fast check. We will do negative 45 minus 12. So we get that from 9 times negative 5 is negative 45, and 3 times 4 is 12. This is not 0, so we can continue. So we're going to solve for each variable individually. So first we're going to solve for x. So we have our x, and the matrix to solve this is we take the answer column, so we go back up to our problem, and our answer column is negative 6 and negative 21. So we write that first. Next we're going to write our coefficients for the y. So 4, negative 5. Next, to get our x value, we're going to actually divide by our determinant value. So for that, we didn't actually solve it, but this was negative 57. So we're going to divide this by negative 57. So all of this together, we get 30. So that's negative 6 by negative 5. So 30 minus negative 84. And once again, that's from these two. So divide that by negative 57. We get 114 over negative 57, which is negative 2. Now that's just our x value. We need to solve for our y. So let's find our y, and we're going to, let's do the next problem down. So for our y, we're going to follow the same steps. So we're going to create our matrix, and we're going to place the x values first. So if you go back up to our original problem, we have 9 and 3. 9, 3. And then we're going to place our answer values. Those were negative 6 and negative 21. So negative 6, negative 21. Once again, we're dividing by negative 57. And then simplifying this, we have 9 times negative 21. Subtract negative 6 times 3. Divide that by negative 57. So this simplified answer, we can simplify even more. So negative 171 over negative 57, which is 3. So we know that our y equals 3. So altogether we have a final answer of negative 2, 3. So we're going to complete the same steps, except now we're going to use a 3 by 3 matrix. So let's bring down our coefficients. We have 3, 4, 2, negative 4, 1, negative 3. And again, I got this 1 from the y. So we have our ghostly 1, as some say, or our invisible 1. And again, we have a 1 here. So let's find our determinant first. Remember, our first step is to copy down the first two columns again. So we have 3, negative 4, 4, 1, 2, negative 3. And then we're going to multiply out to find our determinant. So we found our determinant, which is negative 14. Now let's solve for our x value, following the same method as the previous 2 by 2 problem. This time we're just using a 3 by 3 matrix. So to start with, we have our x equals, and then our matrix. We're going to start with the solution variables. So the moving back up to our problem, we have 18, negative 13, and 11. Next, we want to use our y and z values because we need to remember that when we're looking for our x, we want to focus on the other two variables, namely y and z. So let's take those coefficients from y. So we have negative 4, 1, and negative 3. Remember that y by itself or z by itself, that's just a coefficient of 1. And then finally our z values are 2, negative 5, and 1. And then we're going to divide by the determinant. So when we simplify this, we get. So we're going to go over how to evaluate this determinant first. So we need to remember that we're always going to start with a positive, move to a negative, and finish with a positive. Now this will make sense later. So positive, negative, positive. Now we're first going to take the upper right hand value, which is 18. So 18 times, we're going to do another matrix here, which is, so we take our 18 and we're going to completely disregard what is in the same column in the same row. So 18, and then we're going to fill in the remaining, which is this. So remember, we're taking this kind of L shape out. So we're left with 1, -5, -3, and 1. We're subtracting, we're going to the second value in the same row. So -4, we have -4. Set up another matrix. This time we're going to do the same thing for 4. We're going to take out what is in the same row and same column. So we have -13, -5, 11, 1. Finally, we're going to move on to our 2. So we have our 2 here, and we're going to take out the same row and same column. So we're going to set up 2, and then we have -13 and 1, and then 11 and -3. Now we have 18 times 1 minus -15, 1 minus 15, excuse me. 1 minus 15 plus 4 times -13 minus 55 plus 2 times 13 times 3, which is 39 minus 11. So when we simplify this, we get -468, and then we need to divide this by the determinant, which is -14. And we get 33.43, or 234/7. As our x value, and we're going to do the same exact process for our y and z values by setting up a matrix for, let's say we set up a matrix for y, we put those coefficient values, take them out, and in its place we put the answer value. So our coefficient for y would be, our matrix for y would be 3, 4, 2, because we're copying down the x ones. Instead of the y coefficients, we're putting the answer coefficients, and finally the z coefficients. And then we're going to solve that the exact same way as before. We're going to put a 3 first, take out this row, this column, and multiply by this. Same thing for 18 and 2. Add that together, get our y value, and do the same process for z. I'm not going to go through that whole process for the in interest of time, but you do follow the same process.